last posted a video for all sorts of reasons, not least the pandemic. And at the moment, I've had to dismantle my lab to make space for family, and so I haven't been doing any work on the hardware. I should be able to put that back together again soon and get back there. But I did dig the computer out lately just to make sure it was still working, and that prompted me to make one small update, which I thought I'd share. So in a video a while ago, I mentioned that I had a version of Microsoft Basic running. Microsoft Basic was Microsoft's first ever product. In fact, it was written by Bill Gates and Paul Allen before they created the company Microsoft. And it was written first for the Altair 8800, which was one of the first ever home available hobbyist microcomputers. It was ported to the 6502 processor in 1976. The first release was for the Ohio Scientific machine in 1977, and that's the basis for the version that I'm using. The sources for Microsoft Basic are all available online, and so I'll add a link in the description so that you can check it out. So I turn the computer on here. Let's just run Basic. So actually I would run, this version here. So here's Basic starting up. Wants to know what sort of boot I have, whether I'm reserving any memory and so forth. And so here it is running. It's loaded into RAM for me, but there's still 23K free. Now, computers of this vintage, the vintage of when this program was written, late 1970s, would have used cassette tape to record and load programs. And obviously that's not something that I'm doing. And as I've shown in previous videos, I have interface to a micro SD card that I use for long-term storage. So what I've wanted to do for ages is to put some mechanisms here into Basic that will interface with the fourth monitor routines in the ROM, so that it can speak to the SD card for loading and saving programs. And that's what I've done this week. So let's just take a look. I just loaded this, so there's nothing here. So let's write a very simple program. And I don't know, count up to 10. So if we run that, there we go. That's all it does. Nothing terribly interesting. Let's save that. Call that prog1. Okay, that's saved. Now let's erase the program again and write a second little program. And maybe this time we'll count 11 to 20. Run that just to make sure. Okay, that's great. Save that as prog2. Right, and so now just to show that it's working, let's load prog1 again. And then let's delete that and load prog2. And great, so now we have basic programs that you can load and save to the SD card that's plugged into that's connected to the computer. And unsurprisingly, that makes Basic a lot more useful, because previously it would just erase everything at the end of the day. And in fact, you can, I've been, let's see if I remember what I call this. I can now load longer programs. Ignore the syntax error, that doesn't matter. Like this, this is the classic Hammurabi program. This is from a famous book of 101 or something basic computer games that came out in the 1970s, and so these are programs that everybody knows. But let me show you something about the files that we've stored. In order to do that, I have to reset here. So let's just do that. Okay. Oops. So here's my disk and the files, and you down at the bottom there you see prog1 and prog2. So let's just take a look at those files, at the contents of those files. In order to do that, I'm going to go into fourth, and then I'm going to set up some utilities that I need here. Load, forload, load, 9load. Great. So now we can look at the details of the file. So let's just take that prog1 program. So let's just hit the magic incantation. File. Oops, F cluster at setter load block. Is that right? Yes. Okay, and then let's look in. So I've just loaded up loaded into memory that first basic program, or loaded the first block of it anyway. So let's have a look in memory here and just see. Okay, so there it is. So this is the program, the basic program loaded into memory. Now, if you look here, we can see some things of the text of the program. We can see those strings. Hello, this is the first program. Here's the second string. That was the second line of the program. So we can see some of the text of the program, but we can't actually see the program as a whole. We don't see a print command. We don't see a for command. And the reason is that internally, Microsoft Basic doesn't store programs as the plain text. It stores them in a compressed format, a tokenized format, to save space and also to make the processing, the interpretation, run faster. So instead of saving the print command, print, it just stores a single character that signals that the print is the instruction. So, but it can't do that. It doesn't compress the text that print will print. So we've got the text here, but what it's telling us is that 97 right there, that's the print command. So what's going on here is the first 2 bytes are a pointer that tells it where the next line is. The next 2 bytes are the line number, so that's A0, which of course this is little endian, so that means it's actually 0A, so it's 10. And then we get the print marked by, and the print command marked by a space, and then we start to get the text, the strings that we've entered. And then further up over here, we'll find where the second line of the program is. Let's see, it was 20, wasn't it? So there we go, it's right there, 0, 1, 4, 1, 4, 0. So that's the 20, line 20, which is also a print command, another 97 followed by a space, 2, 0, and then that's where the second text is. And these pointers here, like the 2614 and the 2629, the 264F and the 2629, those are pointers that BASIC uses to tell it where the next line occurs, so that it can skip from line to line, even though lines are of different length. So what my program is doing when it saves the program is that it dumps out the part of memory that stores the tokenized format that's been stored internally by Microsoft Basic. That means the program doesn't have to be tokenized a second time, which is great, but it does mean that it's specific to Microsoft Basic. Only Microsoft Basic is going to use quite this format, and that's why I've been labeling these files as prog1, for instance, .msb for Microsoft Basic. It's not a generic basic text program. It's specifically the Microsoft Basic format. You could write a load save routine that used the text if you essentially would be using the list command in BASIC, and which expands the tokenized form, and you'd be using that to save. And similarly, you could load in by hooking into the interpreter routine so that it would do the tokenizing. I didn't do that here because this was just a way to do it that was easier and didn't involve quite such extensive delving into the internals of Microsoft Basic. This mechanism is pretty self-contained, but I might change that. Maybe I'll do that for the other BASIC that people often run on the 6502, which is Enhanced Basic, EHBasic. EHBasic's it's based on Microsoft Basic. It's a much more it's a more recent product. It's also something that's much more extensively documented, and that's great. But I kind of liked the idea of being able to run this vintage 1970s software on my computer. So that's what I've been doing. That was just a few hours of noodling around last week to make that. Hopefully, I'll be able to get back to working on some of the hardware again soon.